Hello and welcome to another past paper session. Again, this paper is from IGCSE Mathematics and the variant is 4.1. This is November 23. Let's start solving. Question number one is about transformations. Describe fully the single transformation that maps shape A onto shape B. So A to B looks like a simple translation. How many units is this translated? I see that the translation is gone down by -1 and how much to the left? Let's check. 1, 2, 3, 4, 5, 6, 7. So 7 and -1 is my translation vector. Shape A onto shape C. This looks like the shape has turned. So I see that there seems to be a rotation somehow. So I'm going to say firstly that it's a rotation. I also observed that it looks like it might be a 90-degree rotation since I don't see any complete opposite shape. So it's a 90-degree. Let's decide whether it's clockwise or anti-clockwise. Um, then the next thing to look for is center of rotation. How do you look for the center of rotation? You say that you join an object and its image and you try to draw the perpendicular bisector. The perpendicular bisector of this line is going to be this dashed line that I'm just about to draw. This is the perpendicular bisector of the red line. Okay, I need another object and image that I could combine and draw the perpendicular bisector. What looks easy? I mean, this should be easy. But I want this line to be dotted solid. Let's switch to a solid line. First, I connect the object and the image, and then I draw the perpendicular bisector. Now, on the exam, you would draw the perpendicular bisector like you've learned in loci. Not without that. Since I don't have a compass on screen, I'm just going to draw something approximate and see if I can sort of get the right answer. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 3.5. So my line should look something like this. I don't know if I'm going to get the right answer out of this. Let me check if my answer is correct. Yes, the center of rotation looks like it's 5, 1, 1, 5, 5, 1. And let's join these by the center of rotation to see what the angle of rotation is. Okay, so this looks like it has gone like that. So it's a 90-degree clockwise rotation about 5, 1 clockwise, and center of rotation is 5, 1. So tough question right at the start. Then says on the grid, draw the image of shape A after reflection on the line y equals to 2. Okay, I will have to erase these constructions because I want to now draw another object and image. Okay, so y equals to 2, y equals to 2 is a horizontal line. Let's reflect this. How do you reflect? You see the distance here and you draw the same distance on the other side. So 1, 2, 3, 4. This point gets reflected here, the corresponding point here, and then 6. This should be the reflection of part B1. Okay, so I'm going to label that B1. Shape A after an enlargement, scale factor -2 with center 0, 0. Okay, so I will now have to do some counting and say that I am starting from 0, 0 and counting to A. Okay, and then whatever vector I get, I am going to multiply that by -2. So I have 2 minus 2 multiplied by -2 gives me -4 and 4. So I'm going to go on and draw that point at -4 and 4 in a bit. Let's count the other points. That's 3 and -2. So into minus 2 gives me minus 6 and 4, and then 3 and 4. 3 and minus 4 into minus 2. I have minus 6 and 8. So minus 4 and 4, minus 4 and 4, minus 6 and 4, and minus 6 and 8. 6 and 8. So that's B2. Okay. Moving on, algebra, find the value of S when A equals to 9.8. Those of you who've done physics might find this equation very similar to what you've done in kinematics and physics. 9.8 divided by 2 into 400, 1960. I hope that's the correct answer. Yes, 1960 is the correct answer. Okay, so I can do this easily by first taking 5 to the other side and saying that 4y minus 3 equals to 3. So 4y equals to 3 plus 3, 4y equals to 6, and y equals to 6 divided by 4. So that's 1.5. Expand and simplify. So 3 times 5 is 15x minus 24 minus 6x plus 14. So 9x minus 10. Rearrange a equals to 2b square minus 3c cube to make c the subject. So 3c cube equals to 2b square minus a. I've moved a to the other side just to make sure that I end up with a positive at the end. So c cube equals to 2b square minus a divided by 3, and c is cube root of 2b square minus a divided by 3. That should be the correct answer. You can write that in the answer space. I see 4 terms, so that is called factorizing by pairing. So I'm going to make pairs. What is common? P, Q is common and 2 is common. 3p minus 2 minus 1, 3p minus 2. So I have 3p minus 2 and I have 2q minus 1. Then I have a standard form question. Let's look at that. I have the table shows information about some of the planets in the solar system: Earth, Mars, Jupiter, and so on. The average distance of Mars from Sun is 2.279 into 10 power 8. Write this distance as an ordinary number. Okay, either you can use your calculators to do this, or you can do this manually by moving 8 decimal places to the right. So I'm going to say 279, that's 3 decimal places, and then so I need another 5 zeros. 1, 2, 3, 4, 5. You can also put commas after every 3 to denote millions. But that's your choice. Okay. The planet Uranus has a diameter that is 35.8% of the diameter of Jupiter. Okay. So Uranus is 35.8% of Jupiter, 143,000. So what's 143,000 into 35.8%? It's 51194. Okay, an exact answer, so that's absolutely fine. The ratio of diameter of Neptune to the diameter of Saturn can be written in the form 1 is to n. The diameter of Neptune is 49,500, to the diameter of Saturn is 125,500. Can be written in the form 1 is to n, so I'm going to write 1 is to n and then cross multiply to find n. So I have 49,500 n equals to 125,500. So 125,500 divided by 49,500. That gives me a very decimal sort of number, so 2.43. Find the average distance of Neptune from the Sun as a percentage of the average distance of the Earth from the Sun. Okay, so that is Earth is in the denominator, Neptune is in the numerator. So Neptune is 4.495 into 10 power 9, 4.495 into 10 power 9, and Earth is in the denominator, 1.496 into 10 power 8 into 100. So I'm just putting that on my calculator, and that's coming out to be 3004.7. So I'm going to say that it's three significant figures to just 3000%. Distances within the solar system are also measured in astronomical units. The average distance of Jupiter from the Sun is 5.20. Astronomical units calculate the average distance of Mars from the Sun in astronomical units. So 7.786 into 10 power 8 is to 5.20, and Mars 2.279 into 10 power 8. 2.279 into 10 power 8 is to X. Okay, again cross multiplying to solve. 5.20 into 2.279 into 10 power 8. Okay, that gives me a very large number, so I'm going to eventually divide by 7.786 into 10 power 8. That gives me X as 1.522. Three significant figures to 1.52. The distance of Mars is 39.2% greater than the diameter of Mercury. Calculate the diameter of Mercury. Mars is 39.2% greater. So it's 139.2% of Mercury. So M Mars equals to 139.2% of Mercury. I can write it like that. Let's fill out Mars, and I'm talking about the diameter. Mars is 6800. 139.2%. Mercury is not there. Okay, Mercury. So it's 6800 divided by 1.392. Okay, in decimals, and I'm getting something like 4885.1, which is approximately equals to 4890. One light year in the distance that light travels in a year of 365.25 days. The speed of light is 10 2.9979 into 10 power 5 kilometers per second. So that one light year is 9.461 into 10 to the power 12 kilometer, correct to four significant figures. Okay, so one light year, this is per second. Okay, how many seconds are there in an entire year? Okay, in a year of 365.25 days, so 365.25 multiplied first by 24 hours, and then each hour has 60 minutes and then 60 seconds. So these are the number of seconds in a year. If light travels 2.9979 into 10 power 5 kilometers per second, and so I'm going to multiplying speed into time to show that the distance of one light year. Light years is the unit for this. It's a measure of distance since it's in kilometers. Let's multiply all of this together. It's a long multiplication. Make sure that you type into the calculator correctly into 10 power 5. So it's coming out as 9.461 into 10 power 12. That's what my calculator is also churning out. So that is the final answer. The distance from Andromeda to the galaxy is 2.40 into 10 power 9. Calculate the time taken for light to travel from this galaxy to Earth. Okay, now light also travels kilometer per second. The distance is 2.40 into 10 power 19, and speed of light is 2.9979 into 10 power 5. The time is distance divided by speed, 9979. So this is going to give me an answer in seconds. So just I need to be aware that I need to divide it by first 60 to change it into minutes, then by another 60 to change it into hours, um, then by 24 to change it into days, and then into 365.25. If I want to change it into years, then it says millions of years. So I'm going to change it into millions by dividing it by 1 million. Okay, let's start doing that. Into 10 power uh, 19 divided by 2.9979 into 10 power 5. Okay, so this comes out as a very large number. It says 8.005. So I'm going to start dividing it by 60 first to change it into minutes, and by another 60 in the denominator to change it into hours, then by 24 to change it into days, then by 365.25 to change it into years. Now, the answer for years is 2536822.801. So I'm going to divide it by a million to say that this is 2.54 million years. Okay. Keep a multiply here, not a divide, because everything is getting divided eventually. Okay, moving on to the next question. This is probability now. It says Lucia has two face spinners. Spinner A has is five-sided and is numbered 1, 2, 3, 4, 5. Spinner B is nine-sided and is numbered this. Lucy spins two spinners and records whether they land on a prime number or not. Okay, so which of these are prime? 2 is prime, 3 is prime, and 5 is prime. 3 is prime and 5 is prime. Okay, so spinner A, the probability of landing upon a prime number is 3 over 5. So the probability of not landing on a prime number is 2 over 5. Spinner B has how many primes? It has 3 and 2, 5 out of a total of 9. Okay, so 5 out of 9 are prime and 4 out of 9 are not prime. Okay, again 5 out of 9 are prime and 4 out of 9 are not prime. Since this is still spinner B, spinner A doesn't impact. The two numbers are both prime. I have a habit of first writing down my outcomes. So I'm going to do that. P and not P, not P and P, and not P and not P. Numbers are both prime, so 3 over 5 into 5 over 9. That's what I'm talking about. So I get one third. The two numbers are not both prime. Okay. Or not both prime is simple. It's just 1 minus one third. Not both prime simply means that both don't have to be prime. So they could be anything else. So that means it's just 1 minus one third. That's 2/3. Or you could add up all of these branches, 1, 2, and 3. Lucius spins the spinner 120 times. Find the expected number of times the spinner lands on a prime number. So on spinner A, there were 3 prime numbers out of 5. If I try out 120 turns, I get 72 prime numbers expectation. Okay. You see a spinner B twice. Find the probability that the two numbers it lands on add up to 9. Okay, so how could they add up to 9? Either I could get a 4 and a 5, or a 5 and a 4. So 4 and 5, or 5 and 4. What's the probability of landing up on a 4 first? It's 4 over 9 because there were 4 fours and there are 2 5s. So 2 over 9 in the next turn. Or I could have 2 over 9 in the first turn and 4 over 9 in the second turn. So I have 8 over 81 multiplied by 2. 16 over 81. Is there any other way of getting a 9? Uh, Add up to 9 or more. Okay, so I missed out 5 and 5 and 5. So 2 over 9 into 2 over 9. So that's 20 over 81. You say keep spinning spinner B until it lands on a 4. Find an expression in terms of n for the probability that this happens on the nth spin. Okay, so I'm going to say that on the first turn she fails, on the second turn she fails. She succeeds on the nth turn. So there might be n minus 1 failures. That means there were 4 fours and there were 5 not fours. So 5 over 9 comes up n minus 1 times, and that one last term gives her her success. So that's one time. So she fails for n minus 1 times and then succeeds for once, and that's 4 over 9. Okay, so there are n minus 1 failures and one success at the end. Moving on to question number 5. This is trigonometry. Okay, let's look at trigonometry carefully. Says ACD is a right angle triangle, B is an AC, and BC is equals to 54.5. AD equals to 83.2, and angle ABD equals to 38. Calculate angle ACD. Okay, this is the angle that I'm looking for. Um, and it's a 5-mark question, so it's going to take a while. Okay, let's first try to calculate this side, and this angle is simple. So it's 180 minus 38, 142. Okay, so how does 142 help me? I can also use this side and then do a collective. I think that's the better way out. I can calculate AB and then use the entire right triangle to calculate that angle. So how do I calculate AB? I look at this triangle and say that I can use SOHCAHTOA or tan, in this case 83.2 divided by AB. Okay, so AB is 83.2 divided by tan 38. 83.2 divided by tan 38. I get AB equals to 106.49. Okay, so angle ACD is then tan ACD equals to 83.2 divided by 54.5 plus 106.49. Okay, so ACD equals to 27.3. I hope that's the correct answer. Yes, that is the correct answer. Then says EFG is a right triangle. A circle can be drawn that passes through the three vertices of the triangle. Okay. On the diagram, mark the position of the center of the circle with a cross. Explain how you decide. So whenever there's a right triangle um, and that makes sort of a circle, remember that the circle property applies that the diameter creates a right triangle at the circumference. Okay, so if you want to draw a circle, you will certainly know that FG has to be the diameter of that circle. It's going to be the midpoint of that. So diameter creates a 90-degree angle on the circumference. Therefore, FG is the diameter. Okay, it's also called angles in a semicircle, whichever way you want to learn that. Okay, but see, in triangle LMN, the ratio angle L to angle M to angle N is this angle. Okay, 4 is to 5 is to 6. In triangle PQR, PQ equals to 6, PR equals to 4. And calculate the difference between the largest angle in triangle PQR and the largest angle in triangle LMN. So for angle LMN, the largest angle will have to be the ratio of 6. So I'm going to divide 180, because the sum of angles of a triangle is 180, in the ratio 4 is to 5 is to 6, and say that the largest angle should be 72 degrees, largest element. Okay, or largest angle n. Okay, I know that the largest is angle n. In this case, the largest would again be the one opposite the largest side, but I can only calculate this using the cosine rules. I'm going to say that cos r equals to 4 square plus 5 square minus 6 square, 2 into 4 into 5. R equals to 82.8 degrees. Okay, so what is the difference? 82.8 minus 72. I am getting 10.8. I hope that's the correct answer. Yes, that is indeed the correct answer. The next question is on sequences. Let's start solving that. It's a sequence, first term, second term, third term. I'll complete the table for the sequences. Let's see what's happening here. I think there's a plus 4 happening. Yeah, so that should be 9. And for the nth term, I'm going to say that it's just a linear sequence. So a plus t times n minus 1. So minus 7 plus 4 times n minus 1. So 4n minus 4 minus 7, 4n minus 11. And let's look at this one. There's a plus 6, plus 10, plus 14. So there are two levels of differences. So I'm going to use my quadratic to do this. And I'm going to say that the quadratic is first term plus first level difference into n minus 1 plus second level difference, which is 4 into n minus 1 n minus 2 divided by 2 factorial 2. Okay, so a is 7, 6 n minus 1 plus 2 times n minus 1 n minus 2. Okay, let's see, 7 plus 6n minus 6 plus 2n minus 2 into n minus 2 plus 2n square minus 4n minus 2n plus 4. So I think 6n is cancelling out, 2n squared plus 5. Okay, I haven't calculated that. This should come out as plus 18. So it's 37 plus 18 is 55. Then let's look at this. It just says 2, 3, 4, 5. So I'm going to say this is 6. This is just n plus 1 in the numerator. I can see that happening. So the number of the term is 1 ahead of the value of the term. The value of the term is 1 ahead of the number of the term. So that's pretty much it. Then in the denominator, I see 3 cube. I see 3 power 4, 3 power 5, 3 power 6. So I'm just moving 2 ahead of the term. So it's just 3 power n plus 2 if you can see that directly. Otherwise, for those n expressions, you can again use a linear sequence and come up with the final answer. So that's up to you. So I see n plus 1 over 3n plus 2. This should be 3 pi over 7. What's 3 pi over 7? 2187. 10 marks. Lots of marks. In a sequence, the sum of the first 29 terms is 7664. The sum of the first 50 terms is. Okay, so 49 terms, 7644. 50 terms, 7975. So the 50th term should have been what? Just a subtraction of the two. 331. Simple question. Let's look at now a statistics question. It says the frequency table shows the time of each 42 athletes in a race. Calculate an estimate of the mean time. So mean is sum of fx over sum of f. What is x? X is the midpoint of these. So 216 plus 219 divided by 2 is 217.5. Then 219 plus 224 divided by 2 is 221.5. 224 plus 234. 229. 234 plus 244 is 239. 244 plus 264 is 254. So I'm calculating the midpoints here. Now I do sum of fx, 9 into 217.5 plus 14 into 221.5 plus 14 into 229 plus 2 into 239 plus 3 into 254. And the entire thing is divided by 42. So I'm getting 226.2976. So that rounds off to 226 to three significant figures. Complete the histogram shown in the frequency table. A histogram is drawn against the frequency density. A frequency density is frequency divided by the class width. I don't have the class width. Let's first calculate that. That's 3, that's 5, that's 10, 10, and 20. So 9 divided by the frequency density is frequency divided by class width. So 9 divided by 3 gives me 3. 14 divided by 5 gives me 2.8, 1.4, 0.2, and I think 3 divided by 20 should give me 0.15. So let's start drawing that. The first one is drawn for you. The second one is 2.8 from 219 to 224. Okay, so 224 should be here, and 2.8 should be that high. Going to draw a line here, go like that. Okay, then the next one is 1.4 for 10 units. Then the next one is again 0.2 for 10 units. Okay, and I think the last one is already drawn. 0.15 is drawn. So have I missed it anything? I think fine. It starts with 216 only. Yeah. Question number 8 is a mensuration question. I see a cylinder, a sphere, and another sphere. Then the diagram shows a solid formed by joining two hemispheres and a cylinder. The radius of the large hemisphere is 5.4. The radius of the small hemisphere and the radius of the cylinder both 3.6, the height of the cylinder is 6.5, show that the volume of the solid is 692, correct to the nearest cubic centimeter. Okay, so it's the volume of large hemisphere plus volume of cylinder plus volume of small hemisphere. Okay, so what's the volume of the large hemisphere? It's 2 over 3 pi, and it says 5.4 in the bottom, so 5.4 cubed. Pi r square h, pi, what's the radius of the cylinder? It's 3.6. So 3.6 square, h is 6.5 plus 2 over 3 pi, and 3.6 is the volume of the small hemisphere. Let's check if that all gives us what we want. 2 over 3 into pi into 5.4 cubed plus pi into 3.6 squared into 6.5 plus 2 over 3 times pi times 3.6 cubed gives me 692.155, 692.156. That rounds off to 692, and that is my correct answer because it was just to show that question. A mathematically similar solid is made of silver. In the solid, the cylinder has radius 0.6. So it's similar, it's 6 times smaller. So the ratio of length is 3.6 to 0.6. 1 cm cube of silver has a mass of 10.49 grams. Calculate the total mass of this silver solid. So I will first need the volume of this. Okay, let's call that x, but this is not the ratio of volumes, it's the ratio of sides. So I'm going to cube it. Okay, 3.6 cubed into x equals to 0.6 cubed into 692. I could also use the let's just use the volume. In fact, it's going to make things complicated if I try to simplify that right now because I haven't already done it. So the volume of the smaller thing comes out to be 3.204 cm cube. 1 cm cube contains 10.49 grams, so 3.204 cm cube will give me what? Into 10.49. 33.6 grams. Okay, let's check. Yep, that is the correct answer. Moving on to part B, it says AOB is a sector of a circle center O. AO equals to 10 and sector angle is 216. Calculate the length of the arc of this sector, giving your answer as a multiple of pi. AOB is sector, it's 10 centimeters. Okay, so it's just simply arc length, so theta over 360 into 2 pi r. Pi r. So 216 divided by 360 into 2 into 10, that gives me 12 pi. Okay, in terms of pi, so that's the answer. A cone is made from joining this sector by joining OA to OB. Okay, so I roll this entire thing up and I make a cone out of this. So uh, so this sort of becomes the slant height of the cone. Okay, that is one thing that you have to remember, that if I join this side to this side, it's going to become a cone with a top at the center and A as the bottom and so on. This is going to roll into the circumference of the base. Okay, I hope you've seen a question like that before. Calculate the volume of the cone. So volume of the cone is 1/3 pi r squared h. Okay, so I think this should be a long question. Okay, so this should be 10. I don't have h. And the circumference of base is 12 pi. So 12 pi can be broken up into 2 pi r. So I get r as 6. So the radius of this has to be 6. Now if I want to find out h, I can find out h. So I get h square equals to 64, h equals to 8. So 1/3 pi 8 square, 6 square, and 8. I can give this answer in terms of pi, or in terms of, I don't see in terms of pi in the answer script. So let's put that in numbers. 301.59, 302. Question number 9 is a functions question. Let's look at that carefully. This is f of 0. I think that's simple to evaluate. 3 times 0 plus 1, 0 plus 5, 0 minus 4. So minus 20. G inverse of x. So you write y plus 3 equals to 2x, x equals to y plus 3 divided by 2. So that becomes x plus 3 divided by 2 when I change this to G inverse. GH of 2. So you can first calculate h of 2, which is 4 power 2 into 4, 2 into 2 minus 1. 4 cube is 64. So what's g of 64? 2 times 64 minus 3. 125. G of 2x equals to 7. So x will get replaced with, how do I calculate g of 2x? I replace every x with 2x minus 3, and this has to be equals to what? It has to be equals to 7. So 4x minus 3 equals to 7, 4x equals to 10, and x equals to 2.5. This is g of x square. So g of x square plus g of x plus 1. So let's first do g of x square. So that becomes 2x squared plus 3. What is g of x? G of x is g replaced by g itself minus 3, right? Yeah. And then plus 1. So I get 2x squared plus 3 plus 2 times 2x minus 3 minus 3 plus 1. Let's simplify that. So I get 2x squared plus 4x plus 1. Have I missed out something? Minus 6 minus 9. This has to be minus 3. So minus 11, yes. H inverse of 16. So whenever I give you H inverse, that means I've, instead of giving you the value of x, I've given you the value of y. So 16 equals to 4 power 2x minus 1. So this becomes 4 squared. So 2 equals to 2x minus 1. X is therefore equals to 1.5. I hope I have the correct answer. Then this can be written in the form, in the expanded form. So let's just start multiplying. F of x equals to 3x plus 1. Let's multiply this. I get x square minus 4x plus 5x minus 20. So I have 3x plus 1, x square minus 9x minus 20, minus not 9x, it's just plus x minus 20. Let's then multiply. I get 3x cubed plus 3x squared minus 60x. I have a habit of writing this in the next line when I multiply with the next number. So plus x squared plus x minus 20. So I get a total of 3x cubed, 4x squared minus 59x minus 20. So 3, 4 minus 59 and minus 20. Okay. Okay, so question number 10 says ABC is a triangle, B is the point this, A is the point that. So I can say that this is OB since I see a vector, and this is OA. And CA is that minus 11 and 8. Find the coordinates of C. I think that's simple if you know how to deal with um, vectors, addition of vectors. This can either be broken down into OA minus OC, or you can say that's CO plus OA with addition of vectors. So CO is something I don't know. OA is 4 and 14 and minus 11, 8. So CO is minus 11, then minus 4 and 8 minus 14. That gives me minus 15 and minus 6. That's CO. I want OC because I want the coordinates. So those are 15 and 6. Okay, you could also plot them up and sort of work them. Find BA. So it's BO plus OA. BO is minus 1 and 10 because OB is 1 and minus 10. And then OA is 4 and 14. So that gives me 3 and 24. CA, the magnitude of CA, so minus 11 squared plus 8 squared. What's 121 plus 64? 185. Root of 185 is approximately 13.6. Part B is again on vectors. OMN is a triangle. OM equals to A and ON equals to B. R is a point such that MR to RN is in the ratio 3:2. So this is 3/5 and this is 2/5 of the entire thing. ORT is the right. There's a straight line. Show that OR equals to 2/5 of A plus 3/5 of B. So OR is just OM plus MR. OM plus MR. I have OM, but I don't have MR. Can I say that's 3/5 of RN or 3/5 of MN? But do I have MN? No, I don't even have MN. Can I then go from M to N? How do I go from M to N? Minus A plus B. So I get A minus 3/5 of A plus 3/5 of B. So I get 2/5 A plus 3/5 B. Then it says NT is 4A plus K times B. Okay, so 4A plus K times B. Find the value of and OT equals to C times OR. OT equals to C times OR. Okay, it's a little complicated. Let's see 4 marks. Okay, find the value of K and the value of C. Let's see if we can come up with a solution where we go from, so NT is basically N to O and then O to T. Okay, so that's NT. So N to O is basically minus B and O to T is C times OR. That is what I have. So minus b plus c times OR. What is OR? OR is 2/5 of A plus 3/5 of B. That's something that I've already done. NT here is 4A plus KB. So let's try to make sense of what this is. 2/5 C times A plus 3/5 C times, not, this isn't a vector, C times B. So what I can then say is that the vectors of A on this side should be equal to the vector of A on that side. So 4A should equal to fifth of C times A. A and A cancel out. C is 4/5 divided by 4 into 5 divided by 2. So C comes out as 10. Okay. Then if I look at B, so plus B and then minus B and 3/5 of CB. So I can say that B should equal minus B plus 3/5 of C times B. Okay. So B, it's KB, sorry, it's KB, it's KB. Okay. Can I factor out a B and say that this becomes minus 1 plus 3/5 of C? So B and B cancel out. Minus 1, and I already have C. So that's 2. So K comes out as 5. So 5 and 10. So this is just about comparisons if you've not seen that before. This is what comparison is about. Okay. Find empty. There's another one. Oh, M to T. So I just found out NT. So I can go from MN plus NT. MN is minus A plus B. That's what we figured out earlier. And NT is now 4A plus 5B. That gives me 3A plus 6B. Okay, differentiate the 3x squared minus 8x minus 3. This is something that you must have learned. The curve has this. Work out the coordinates of the two stationary points. So how do you find stationary points? By equating your differential to 0. Okay, so solving this with a quadratic formula. So let's solve this on a calculator. Uh, 3 and minus 1/3. Let's check if those are the correct answers. I don't get anything wrong. I need to still find the y coordinates, so I'm going to find the y coordinates by plugging them in. Y equals to 3 cubed minus 4 times 3 squared minus 3 times 3. That should give me minus 18 and minus 1/3 cubed minus 4 minus 1/3 squared minus 3 times minus 1/3. And that should give me 14 over 27. An easy question at the end, determine whether each point is a maximum or a minimum. So you have to calculate the double differential. What was the first differential? It was 3x squared minus 8x minus 3, I think. Yeah. So I double differentiated 6x, so it's d square y over dx squared, 6x minus 8. Okay. I plug in my first number, I get 10. And then I plug in my second number, that is this, minus 10. So a positive means a minimum point and a negative means it's a maximum. Okay, so x equals to 3 is minimum and x equals to 5 minus 1/3 is the max. Okay, yeah, that is the end of the exam, I think. Yeah. Okay, I will see you with another past paper in the next session.